Hello, everybody, and welcome to Love My Tool TV, and pardon what I sound like. Today, we've had a great chance to talk to two great friends. Of course, everybody knows Keith. We've talked to Keith many times, and now we have Jim today from ExtraHop. We're going to talk about visibility, how to increase your performance through visibility. And I'm going to turn it over to Paul Offord, one of my good friends and also one of our regular authors. Take it away, Paul.
Okay, thanks, Tim. So, as Tim said, we've got a great show tonight. It's got some good information to share with you, two real experts in the industry to talk to us about network performance. Before we go, I'd like to just give a quick plug for SharkFest Asia. Let me look at the details here. It's happening in Singapore, April 9th through to 11th. On April 9th, Laura Chappell will be running her Wireshark troubleshooting with Wireshark course, and then there are 2 days of great presentations from people like Hansang Bay, Phil Shard, Kerry Rogers, Sake Block, and Werner Fischer, and there's others as well. So if you're in the Asia Pacific region, you could do yourself a real favor by going to that event. So let's move on. Let's start by introducing everyone. Keith, could you tell us about yourself?
Yeah, hi everybody. Keith Bromley here. Formerly with IXIA, we've been bought out by Keysight. We still do the same things though. We've got network security, network visibility, network testing, and then have the great products from Keysight as far as network and layer 1, layer 2 testing capabilities.
Okay, thank you. Jim.
Hey, so my name is Jim Sullivan. I am the channel SE for ExtraHop in the west of the US. Of course, I travel around the world in my role. And at ExtraHop, we're taking that traffic that IXIA is putting together, and we're making sense of it. And we'll talk a little more about that. But I've been in the industry a while, and this is when I saw it, I thought it was revolutionary, and it's only gotten better.
Okay, great, thank you. So, Keith, network performance, visibility. Tell us what you know.
Well, I know a few things, and I know Jim knows a lot, so I think it's going to be a great session here. One of the things we've done in the past, we've talked about network visibility and visibility architectures, where you've got the access layer, so you've got some sort of span, tap, bypass switch where you collect data packets, and then you feed them over to the next layer, which is like a processing layer, where you've got a network packet broker that can go through and manipulate, deduplicate, filter out data, do aggregation, and so forth to the data. And then the data sent on to the tool layer, where you've got security and monitoring tools that take that information and actually process it and do something actionable with the data. So we've talked about that in the past, and we sort of want to come back and revisit a little bit today. But take it to the next level. How do you really unleash the power of your network visibility? And this is going to be the first in a series of podcasts on that. And today we wanted to focus on network performance. And so, like I said, I mean, the packet broker is key to the visibility solution. It is what goes in and enables you to have the ability to segment out data, whether it's by VLAN, IP address, port tag, whatever. You can take that information, aggregate different flows of the information, get rid of irrelevant extraneous data that doesn't need to be sent to a tool, and then funnel that tool or replicate it and send it to multiple tools. But give the tools the right information that they need, so they've got the right information at the right time to do what they need to do and come to resolution faster. And that's where solutions like what Jim has from ExtraHop, where they can go in at an application and network performance layer and optimize that data, really comes into play. So I don't know if you want to talk more about that, Jim.
Well, and the thing that came to mind was the issue of EastWest versus NorthSouth. And when you talk about visibility, a lot of the visibility tools we have today, they're very much focused on what's coming into the network and what's going out. And that's important. I mean, data gets exfiltrated by going out. But the way that data gets collected is through the EastWest. And if you don't have visibility about what's going on in that layer, you're in some sense, you're blind. And the amount of traffic that runs inside the network is exponentially greater than what's going outside, if that makes sense. And so being able to understand what's happening in that space and filter through it and make data-driven decisions is really important. And that's where, you know, you're going to have all this information, and how do you bring it together? And that's where, you know, packet brokers come into play. That's where the ability to kind of filter down and say, this is what I'm really interested in.
Yeah, because one other thing I was going to say there, you just prompted me on it, because a lot of times I come from the on-premise environment, but EastWest data in a virtual data center or even a cloud network, that can be trouble, you know, to go in there and get access to that data. You need to put the right kind of virtual tap in there to actually pull the data out. And then if you want to do application performance monitoring or troubleshooting or something in those environments, you really need that packet data. You can't use summarized flow data to really get down there and analyze the problem. So again, it's getting access to that data.
Yeah, and a lot of people say that, I've had several people say virtual taps are nothing but RSPAN, and that is a myth. That's not RSPAN. RSPAN, trust me, is a lot more problematic than a virtual tap. But a virtual tap is not a inline tap. It has very limited gap time. So again, as Jim said, and you've said 100 times, Keith, is got to have visibility. You got to understand what visibility you got. Then you have to take that and actualize that into something that you can use. Understand your network, understand when there are problems, and things like that. So sorry.
I think from my point of view, because Advanced 7 does an awful lot of analysis both in on-premise and cloud environments. The challenges that are coming up for us are definitely things like speed of the data, remoteness from the data center, and just as you were saying, Keith, about the ability to change configuration of monitor sessions remotely is definitely a very big thing. But I do agree with Jim that a real challenge is east-west in virtual environments, and now, of course, in Docker containers and things like that. It's gradually becoming more and more abstracted, and we're working on quite a large containerized system, and that's a challenge, you know. So
well, you go blind.
I'm interested to hear about that.
I mean, your tools are all designed. A lot of our tools today are designed around infrastructure and ideas that are, if not decades old, millennial old. And I believe everybody on the team is at least millennial old. So, but you know, that hinders us as we go into new spaces. So as you go into the cloud, the things you were trying to do in the cloud aren't as effective anymore. They're hard to deploy. It's really hard to take an appliance and stick it in a cloud. You don't have it. It's somebody else's computer. And you know, years ago, I think it was in 2011, I think Mark Andreas said, software is eating the world. And it is. Data's now joining, you know, bellied up to the buffet and is eating as well. And you know, the beauty of having tools that are not reliant on physical, but enabled you in a software environment, means that when you have containers, when you have Internet of Things, when you have microservices, you're just going to watch how they work on the network. Yeah. And that manifestation will tell you what's going on.
Yeah, absolutely. And there you have the kingpin, the sort of crux of what we do at Advanced 7. I mean, we do an awful lot of network analysis, but we're hardly ever looking at network problems. Nearly everything we look at is application, database, you know, something else, microservice, as you said. So getting the visibility, particularly, I guess, and I guess I'm setting you up nicely here for at the TCP layer. You know, getting that visibility at that layer is so important to us. So, Keith, tell us a bit about virtual taps then.
Well, so virtual tap, like Tim said earlier, it's really just software. So you can put it into the virtual data center, load it into a VM. You can get access to EastWest data. You can pull it out. You can export it through like a GRE tunnel if you want, send it over to a packet broker and send it to physical tools. You can actually still grasp the data if you want it and keep it in the virtual data center and send it to virtual tools. In the cloud environment, it's sort of a similar thing. Instead of a VM, you're probably going to load it into a Docker container, and then you can actually go in and grab that packet data. Because again, like I said, a lot of people, when they shift over from on-premise to cloud, they think they're going to have a complete replication of what they had, the applications, the appliances, everything like that is just going to move over into the cloud, and it doesn't. You run into problems where you don't have access to the data. You've got summarized flow data, and then you've got, especially in a troubleshooting situation or APM, you have issues that you need to resolve quickly, and a lot of the data is aging fast, and so you need to get that data, grasp it, and send it to your tool as fast as possible to come to a resolution. Otherwise, you're going to have network downtime, slow applications, customer, whether they're internal or external complaints. You get into a whole slew of problems you really don't want to face otherwise.
I think the challenges I see coming up as people move more systems into the cloud, and we've certainly also got customers that are running hybrid solutions, is that demarcation of responsibility. You know, is it a on-premise issue, or is it a problem in the cloud provider's infrastructure? If you don't think that problems happen in the cloud provider's infrastructure, they do. I can tell you. Yeah,
so, exactly. I was going to say. I mean, so
how are you going to prove that? You know, and I think that's where what you're saying is definitely a strong point.
Yeah, I mean, how do you prove it? So you've got to get your own data there to go and prove what's happening, not happening. But the biggest thing, like I said, is just getting the data. Back on the hybrid, that actually, depending on what you're doing, when you're doing it, how long you're doing your migration from on-prem to cloud, hybrid is a good scenario. It might last for a year, 2 years, 3 years. Maybe you make it permanent, because again, if you've got the right sort of virtual tap that's in that cloud environment, you can go and export the data that you want and export it over to on-premise to your network there. And if you've got appliance-based tools, you've got just existing tools that you want to maximize the ROI for, because you want to keep using them. You don't want to buy a brand new copy of some of the tools you can in the cloud environment. Use the export capability, send it over to the on-premise, and get the best of both worlds.
Jim, how do you see this playing? How does ExtraHop cope with these types of scenarios? What are typical setups for an ExtraHop customer?
Well, so we're actually really well positioned for that type of hybrid cloud on-prem mix. And, you know, we're software. The beauty of the ExtraHop appliance is that we are just software. I happen to provide it in some formats that look suspiciously like a Dell box, but it's still just software. And so what that means is when you're on-prem, you can have a physical box and you can scale to 40 gigabits. But when you move into the cloud, you can take that same software and deploy it in the cloud using the virtual taps that IXIA are providing and have that same visibility. And so what we see our customers doing, and I think this is pretty common, around the world, is there's certain data that you do not want to put in the cloud for either, regulatory reasons, you're not allowed to, you can't ship that data out of country, or just because, you feel better not having your customer lists up in the cloud. Yep. But you want to have the scalability that the cloud gives you. So you make that jump and you end up with a hybrid environment of stuff up here and stuff down there, and they're working back and forth. And then when it doesn't work well, that network visibility in both places gives you the ability to essentially track a transaction that may start in the cloud, come down to the data center and go back out and see where it's slow. And this is something our customers deal with all the time. And they'll be working with a third party and they'll have a problem. And the third party inevitably says, it's not my problem. I don't blame them. It's never my problem when I have a problem. It's always yours. But then it gets down to proof. And how do you prove these in a network environment? Well, you get a PCAP. You know, I'm sure at least one of the people on this call has a T-shirt that says PCAPs or it didn't happen. And how do you narrow into that? And that's where our ability to start with the conversations, drill to the transactions, and get you the packets becomes very powerful. So give us that data feed, and then I'm going to make sense of it for you in a way that you'll probably never be able to do.
Well, the imperativeness of having an active view is when you're in the cloud, your visibility ages, because what was in the cloud 30 minutes ago is different. And you need to have that actionable item and actionable visibility as quick as possible. And that's, you know, and also put it in human sense. One time, a friend of mine, everybody here knows him, but I won't mention his name. He said that he doubted if 95% of the people that used open source tools could even follow a TCP IP stream. And today, that is so minimalistic in the whole perspective of how you monitor, manage, and help grow, protect your network. So you have to have that actionable item.
Yeah, I think the thing is that, and you know, I'm a big fan of Wireshark and packet analysis. But if you're in an ops environment and you need faster visibility and sort of more real-time ongoing monitoring, you know, taking what is effectively batch processing trace files and taking them and then looking at them is a slow way to an answer. And if you can find faster ways, then
it's impossible. It's the wrong way. And the reason it's the wrong way is that I know that sounds aggressive, but if the data flows at you faster than you can process it, you will never catch up.
Right.
You're done. Right? And in a world where networks are 10 gigabits or 40 gigabits a second, I mean, 40 gigabits a second is 5 gigabytes a second. That's, you know, which of those, you know, where's the 10K of packets that I'm really interested in that? And oops, it's gone.
Yeah.
And so this is where you need to you need to do the analytics first in these environments, because that gives you that deep insight. Right. You need to, if you're not auto discovering your devices, you don't know what's in your network.
Yeah.
This is, you know, the classic problem is, I don't know why, but it looks like somebody just added a wireless access point and just smashed everything to bits, whatever. And that happens all the time. People plug things into corporate networks that they really shouldn't. And we, you know, once you have that network visibility, once you're bringing all those pieces together, you can then start to get some insights. And I'm going to share something here because we talked about this earlier. But this is what you get when you give an ExtraHop appliance the visibility you need. So we're getting this from, you know, the taps, this is the network. Every dot on that map, that's a device. Automatically discovered, no agents. We just saw it talking on the network. We have its MAC address, IP address, machine name. We know who it is. And every line is a conversation or multiple conversations. And if I just say something as simple as, what I really want to see is just my database servers, I can do that.
Yeah.
Right? And, you know, the comment about what was happening before, I can actually do a comparison. Compare to what was happening yesterday.
And how much are things like encryption and HTTP2 and things like that going to stymie this visibility? Is that going to, you know, make a lot of this opaque to us?
Yes and no. I should stop sharing here. So for you know, for data centers now, more and more traffic is being encrypted. This is the reason people are doing this is twofold. Mostly because they know someone's snooping around in their network and they don't want them to see it. Right? It's the belts and suspenders. I have a lock on my inside door, so that, you know, whatever. So if you are blind to that, you can't see those conversations. And that significantly impacts your monitoring piece. So with ExtraHop, we've always we've had SSL decryption, and so I know IXIA does the same thing.
Yes.
You can decrypt that traffic and feed it to us. We just recently announced a solution for perfect forward secrecy, where those are private keys. They're negotiated in the conversation, and we can see them as well now.
Okay.
So once you expose that information, that 40 to 60% of your network and going up suddenly is no longer opaque.
Yeah.
You can see what's going on there.
Yeah.
And I think that's the key point there, Paul, is that, like you said, the data has to be unencrypted. You've got to unencrypt it somewhere in the network, and then you can go in and analyze it. So that's one thing that hopefully everybody in IT is keeping in mind, that okay, you're going to use an encryption, you're going to protect stuff, but at the same time, you're also going to be unencrypting it, and you need to be sending that data to the tools, so unencrypted data, so that it can actually be processed and used.
And you don't want those tools storing those unencrypted packets, though.
No.
Yeah.
It's kind of, oh, I have everything encrypted, but I've decrypted it all. It's all over here. Just go. Here's the honeypot.
Yeah.
Yeah, exactly.
And that's
Because
why,
then
you get back to you need to process it in real time, extract the information, and then let them slip away.
And then maintaining the metadata, the associated metadata, or you're sort of the mind of scrapping everything.
So we're gonna save the metadata. We will save the transactional information. We'll actually save the encrypted packets. But throughout that entire chain, we only have you only have the metrics, except for when you get to the packets.
Yeah.
But that sort of an encrypted database transaction, I can tell you who the client, who the server was, how long it took. Is it a network problem why it's slow, or is it an application problem?
Yeah.
Or is it an application chain problem? And then drill you into the actual transactions that relate to that.
Yeah.
That's what I was going to say earlier, is that that's one of the big fights we're going on right now. We're trying to make sure that TLS 1.3 allows us to look at our internal data, because a lot of people want to stop that. They don't want anybody looking at encrypted data except them, which would be the big carriers and transport vendors. So
I tell you what I find interesting about this whole thing. Two comments I'd make. The first one is, I think a lot of the drive for encryption is just driven by the fact that it's now just a tick box option in some XAML file or some configuration file somewhere that says, I want to encrypt this stream. And, the application developer thinks, well, why not? Might as well. So that's the first thing. And the second thing is, if you notice, trading systems still don't encrypt, and that's because of speed. Yeah. So it's okay. Everybody's really mad about encryption until it means hit on performance on a critical performing system. Then suddenly it doesn't matter. So I've got a fairly, to get, you said about snooping around on the network. You've got to get through the front door of the data center, open a rack, get a piece of equipment into it, get a monitor session configured, and you've got to get access to all of that. I think it's all going a bit mad, but I can't see it changing.
Yeah. Well, now it's the old guys, but the reality is that I do want that data encrypted.
Yeah,
right?
yeah.
Because
from
a security point of view, right? There's this idea of dwell time. Right? People get inside your network and they sit there. They sit quiet. Right? Mm-hmm. WannaCry was a failure. Why? WannaCry was a failure because it got loud.
But don't you think that APT attacks don't happen by someone watching packets, do they? They happen by someone accessing data on a server.
Yes, but then the malware that's associated with that's then using the network.
Yeah.
That's then sitting quietly, just going out and touching your file servers. And this is where, if you're not seeing everything, you won't notice that this client who never talked SSH before suddenly started to talk SSH.
Yeah. No, I see that point. Yeah.
Right?
No,
and this is where I come back to the volume. And if you can apply machine learning to that, which is, again, something we do, you can then start to say, aha, Why did this database server who never talked to this client before suddenly give him a gigabyte of data?
Yeah.
That seems wrong.
Okay.
And
Well,
in most cases, you'll never see that on the network because you won't have that depth.
Well, that's where visibility comes in, because if you don't know what's normal, you're never going to know what's not normal. Okay. And I tell people that, and I go way back, okay, where just did basic baselining was so imperative, because it'd be like, in some cases, we used stopwatches in the old days. And because we didn't have, don't laugh, it's not funny. But
that was just a year or two ago, right?
Yeah, no, not for me.
I'm gonna say I did the same. So I'm like, not.
Yeah. So to me, the fundamental of visibility is I at least know what my network looks like. Hopefully, when it's healthy. But if you don't know what aberrant behavior is, you're dead in the water. You'll sit there, and that's why a lot of these data leaks last years. I mean, we just had one recently that's not been published yet. 794-day leak. And you know how they found out? A anti-hack vendor, a guy who does a lot of research, found all this data and started looking at the dates of the log files and presented that to friends over in Europe, who then said, oh gosh, this has been breached for 3.5, 4 years.
Yeah. And that gets back to what we've been talking about a lot, that the real power of what you want to do is based upon visibility, whether it's security, troubleshooting, performance. You've got to have visibility. You've got to have the data before you can then go and do anything else. Otherwise, you're going to be blind. You got too many blind spots in your network that are just in some way they're going to hurt you.
Yeah. So make data-driven decisions, and understand that the flip side of the baseline, by the way, is people put up with poor performance because that's the way it always been. Right? Yeah. It doesn't perform well. Well, it's too bad. Yeah. It always took. It always took forever.
Yeah.
And so, and we waste time. One of our classics is DNS for an ExtraHop environment. The protocol that always works, even when it doesn't. Yeah. And we have instances of 98, 99% DNS failure.
Yeah.
There's nothing wrong with my DNS. It just means that it failed 1, 2, 3. The fourth time worked, but it took you 8 seconds to get there, and that was normal.
Yeah.
And when you have the network visibility and when you can parse it out, right? When you bring that all together, that's when you can go and say, "Aha, I need to fix this."
Yeah.
And this is where the layer 2 to 4, you need to get into layer 7.
Yeah. Okay, that's interesting. I can see there's more to be discussed here. Unfortunately, we've run out of time. We're just coming up to our 30 minutes, but let's just have a around the table. Keith, give us a closing comment.
So my main mantra is visibility is the key to everything. Go in and plan it out. It's not that difficult. Visibility architecture, like I said, you've got the access layer, figure out how you want to access the layer, go in then with a packet broker, whether it's a virtual packet broker, physical packet broker, so that you can then manipulate the data how you need to get it to the right tool. And of course, you're going to know which tools need the data and go from there. But that's the key. Just put a visibility architecture in there. It only takes a few minutes, and that enables everything else you want to do, whether it's security, performance, troubleshooting, compliance, whatever.
Okay. Jim, what's your view? Closing comment.
If you can't see it, you can't improve it.
Yeah.
If you don't have a baseline, how do you know you're making it better? At the end of the day, everything in your environment runs on your network. You should treat it well.
Great. Tim, got any final thoughts?
Yeah, visibility is the key. I don't care how you want to argue. If you can't see it, like you said, you ain't ever going to know it's broke. You're never going to know how to improve it, and might as well quit looking at it if you don't have access. And I want to point out one thing, though. As we move into the photonic domains. We have to quit looking at visibility as a last thought. Quality in fiber optics is the essential value because it's no longer just a copper cable and an RJ45. Okay.
Yeah.
You've got a bunch of other problems to handle. Make sure you buy quality technology or you will regret it. And
Okay.
the worst time to find out that it's bad is when you got problems.
Yeah. Okay. All right. My own final thought is I'm up for anything that puts the science back into troubleshooting, quite honestly, and visibility is definitely part of that mix. Okay. Well, thanks very much, everyone. And if you're watching live, thanks for attending. And for those of you who didn't, hopefully you'll be catching up on this later. That made a lot of sense, didn't it? Okay. Well, I look forward to seeing you again soon. So thanks very much to all our presenters, and goodbye from LMTV.